My name is Wilbur Alderjust, and my group members are Naira Foster and Brian McLean. And our two main project ideas would be the bike transportation system and the baby no bye-bye system. So we'll first start with the bike transportation system. So time is a precious commodity, especially to students. When dealing with school and other aspects of life, any way of saving time would be welcomed. The FAU Boca campus is approximately 850 acres, and much of it is occupied by campus structures themselves. Because of the campus's expansive real estate, students often find it time consuming to travel from one end of campus to the other end. One way that the students can save time navigating across campus is by the use of convenient transportation system, which can be incorporated seamlessly into current campus life. The school has implemented transportation systems that have tried to alleviate the issue of having to navigate great distances across campus. The available campus transportation system involves the shuttle bus and the carpooling program and the Go Green initiative. The shuttle bus itself runs during a particular service hour. There are currently two shuttle routes operating on campus. The issue with the shuttle bus is the fact that the bus itself um, runs on a particular schedule and it may not fit within the schedule of particular students. And also, the buses only operate at certain times throughout the day and only operate on certain days. The carpool system itself is not convenient because the majority of students are going to classes individually with different schedules, and this solution requires students to synchronously meet on a particular schedule and to travel together in one vehicle. Our solution would be to incorporate an on-campus bike transportation system where students can use their OWL card to rent bicycles from a station and use that bicycle to transport themselves to another station located across campus. The station would be a bike rack that uses a mechanism to lock the bike to the rack itself. There would be a number of stations that are strategically placed throughout the campus in areas that are isolated from the main parts of the campus. The bike's availability would be based on whether a bike has been racked at a particular station, and the bike's availability would be displayed on an application which could be accessible to students. The students would swipe their OWL card at a bike station to rent the bike. The student would assume responsibility of the bike's well-being until it has once again been racked. The parts of campus that the bike racks would be placed would be at the SS8 building, the Engineering East building, the freshman quarters, otherwise known as the Innovation Village Apartments, the gym arena, and parking lot 5. The reason why these areas were chosen was because these areas are typically isolated from the main parts of campus. To monitor the bike transportation system, there would be an app that both displays and tracks the bike's location on a map via GPS. A GPS transponder would be integrated into the bike, and the GPS transponder would notify the system that the bicycle has been taken outside a predetermined perimeter. Every bicycle would be trackable in real time via GPS. Now we're going to speak about the challenges of this project. One challenge would be preventing theft of the bicycle itself. The tracker would have to somehow be fastened to the bicycle to prevent the removal of the tracker. Another challenge would be incorporating low power consumption to the GPS transponder. Another would be preventing the theft of the bicycle wheels themselves, keeping the bicycle maintained for longevity of the bicycle itself, keeping the cost of the project low because of the amount of bikes that are required to demonstrate the project and the amount of sensors that will have to be placed on each individual bicycle. And the issue of an overflow of bicycles at one particular station and there not being enough space to rack the additional bicycles. The unknown would be the total cost of the project and the total yearly maintenance costs of the project.
Hi everyone, this is Brian McLean, and I'll be going over my idea, the baby bye bye system. One of the problems that made me pick this design was that because on average, um, 37 children die from heat related deaths after being trapped in vehicles. Even the best parents, the ones that are attentive and they're good caregivers, they unknowingly leave their kids in the back seat, um, and the end result can be death or injury. And so far, 16 confirmed children deaths have been linked to vehicle heat stroke in 2018. Um, for a total between 1990 and 2016, there has been 793 confirmed deaths. That's an average of 37 deaths per year, make once every 9 days. The significance um, of fixing this problem is because the children are our future, and vehicle heat stroke deaths are preventable, and we can help reduce the amount of children who die needlessly. So my solution for this issue is a car seat called Baby No Bye Bye. And so it's an infant car seat that has sensors on it that will know when the baby's in the car seat and will also know if there's any people in the car um, by tracking any motion in the car. So, and if there is no one in the car and there's an infant in the seat and a period of time has passed and while the infant is in the seat, then um, the driver will receive a text message. And if that goes unanswered for a period of time, then the authorities will be contacted. Um, some of the challenges with the design for right now is implementing a presence sensor that works at a low frequency is that poses little risk to human health and doesn't interfere with the vehicle's equipment, also including your cell phones or anything else that uses signals to like Wi-Fi, Bluetooth, anything like that. And the second issue is due to the current design and the sensors that we're going to be using for this design. If the sensor will also pick up any animals that are that's left in the car, and it will determine that that animal is a human presence since it's tracking for any movement. So there will be no alerts until the temperature in the car increases, and then the driver will get an alert, and then the authorities will be contacted. Okay, so some of the devices that are going to be used in this system. some of the input devices. Some of the sensors that I was looking at are microwave sensors, and another sensor is a human presence sensor, and the item numbers are listed. Um, the power regulator, which will supply the microcontroller, the sensors, and other hardware for connectivity that will be connected to the system. The second would be a temperature sensor, which will track the temperature to make sure that the temperature is not within is within a safe range. The processing equipment will be the Arduino microcontroller. It will receive and interpret incoming signals from the sensors and and also the controllers of any output devices connected to the system. And the output um, devices will be the GSM and the GPS board. SIM 808 is the one that I'm currently looking at, and a speaker to the chime in the car. Um, let's say that if there's a person still in the car, but the temperature is getting high.